Today I am going to discuss the michaelis-menten equation, Eadie Hofstee equation, Lineweaver Burk equation. First, I discuss the derivation of michaelis-menten equation. Derivation of michaelis-menten equation. This michaelis-menten equation depends on enzyme catalyzed reaction. First, formation of enzyme substrate complex. React with enzyme reacts with substrate to form enzyme substrate complex. First, the rate constant K1, this equation rate constant, forward reaction rate constant K1, backward reaction rate constant K minus 1. Now, enzyme substrate complex decompose to form product and enzyme. This rate constant suppose K2. This rate is the slope. So this is the RDA step. In the kinetics, we know the RDA step is the follow the rate law equation. So rate equal to K2 into concentration of enzyme substrate complex. This is the complex enzyme substrate complex concentration. Now this concentration, this is the intermediate step. This is the intermediate step. So this value will be calculated by applying steady state approximation. Steady state approximation on it. Des by dt equal to des dt equal to K1 into concentration of enzyme and concentration of substrate minus K minus 1 ES to decompose the product and enzyme. So this is the rate constant K2 and enzyme substrate concentration. This equal to 0. But enzyme concentration cannot be determined experimentally. So we apply enzyme conservation equation. So enzyme conservation equation E naught equal to E plus ES. E naught is the total enzyme concentration which can be measured. So concentration of E equal to E naught minus ES. Number 1, number 2, number 3. Now this value put this equation. So K1 into E naught K1 E naught minus ES into substrate concentration minus K minus 1 ES concentration minus K2 ES equal to 0. Multiply Q1 E naught S minus Q1 ES into S minus K minus 1 ES minus K2 ES equal to 0. Then common this value K1 E naught into S minus ES comma K1S K1 substrate concentration minus K minus 1 minus plus K2 equal to 0. So ES equal to K1 E naught concentration into S by K1 S plus K minus 1 plus K2. This value put the first equation. First equation is D rate equal to K2 into S. K2 into K1 E naught into substrate concentration by K1 substrate plus K minus 1 plus K2. Now divided K1. So K2 enzyme substrate by K1 S plus K minus 1 plus K2 by K1. This value divided by this equal to K2 E naught substrate concentration by substrate plus K minus 1 plus K2 by K1. This is the value of Km. Km equal to K minus 1 plus K2 by K1. This is the michaelis-menten constant. This is the michaelis-menten constant. So this is K2 E naught ES by substrate concentration plus Km. That is rate equal to K2 enzyme substrate by Km plus S. This equation is most important for CSI and NET gate. So this equation very important equation. Now three conditions apply on this equation. Three assumptions or three conditions apply on this equation. Equation the rate equal to K2 E naught S by Km into S. First condition, three condition. Km, this mutually maintained constant Km very greater than substrate concentration. Km very less than substrate concentration, or Km equal to substrate concentration. Now this Km very greater than substrate concentration, so substrate concentration will be negligible. So rate equal to K2 E naught S by Km. Now this substrate concentration is very greater than Km, so Km is negligible. So rate equal to K2 E naught substrate concentration by substrate concentration. Km equal to Ks, so rate equal to K2 by E naught into S by S, Km substituted by S plus S equal to K2 E naught substituted by 2S So K2 is by 2. K2 is by 2. Now this is the constant value. So this is the K and E naught is. So rate in this equation, rate is the first order with respect to substrate concentration. This S value cross, so K2 into E naught. This is the zero order reaction with respect to substrate concentration. No substrate is there, so substrate concentration equal to 0. So substrate, it is the zero order reaction. This is the maximum rate, nu max by 2. Nu max equal to K2 into S. This is the very important. Now rate equal to K2 into S substituted by nu max into substrate concentration by Km plus substrate concentration. Another equation is there. Plot of this equation, rate versus substrate concentration. This is the plot. This is the Km very less than substrate concentration. This is zero order reaction. This value substrate concentration will be less. Km very greater than this. This is the first order. This first order case, and this is Km equal to substrate concentration. This is the nu max by 2 case. Now we derive this equation to Lineweaver Burk plot, or another is Eadie Hofstee equation. This is most important for CSIR NET gate related question. I will discuss in the next video on previous year related CSIR NET gate. Now rate R equal to nu max into S by Km plus S. This is the value. In Lineweaver Burk plot, rate 1 by R versus 1 by S. This is the Lineweaver Burk plot. Now 1 by R equal to Km plus S by nu max into S. So divided Km by nu max into 1 by S plus 1 by nu max. Now 1 by R equal Km by nu max into 1 by S plus 1 by nu max. This is y equal to mx plus c, this equation. So plot 1 by R versus 1 by concentration of substrate. This is the plot where it is the slope of this equation, and this is the intercept. So intercept equal to 1 by nu max and slope equal to Km by nu max. This is very important plot. intercept equal to 1 by nu max and slope equal to km by nu max. Now the next Eadie Hofstee equation. Next Eadie Hofstee equation. In same equation we apply Eadie Hofstee equation. Eadie Hofstee equation or Eadie Hofstee plot. This plot rate by substrate concentration versus rate or R. Now R equal to nu max into S by Km into S. Multiplied both sides, R into Km plus R into S equal to nu max into S. Now R into Km equal to nu max into S minus R into S. So common concentration of S, concentration of S. Now mu max minus R. Now divided R by S and also divided by Km. Nu max minus R by Km equal to nu max by Km minus R by Km. So R by S equal to nu max by Km by R by Km. This is the another equation. Now plot R versus R by S versus R by S versus R. This is the y equal to mx minus c. So this plot. So slope is this is the slope equal to minus 1 by km and intercept equal to equal to nu max by km. This is also very important plot. Now another is catalytic efficiency. Equal to K2 by Km. Remember K2 by Km. Km michaelis-menten constant and K2 decomposition rate constant. This equation and turn over number equal to K2. These two are most important. In next video, I will discuss this question approaching part. How will we approach this question and solve very easily? So equation is most important. First equation, the most important, and another equation. This first equation derived the another equation. First Eadie Hofstee equation and second Lineweaver Burk equation. Share, comment, and subscribe. Thank you.